So I guess I'm doing that like YouTuber thing with the little tiny mic here. Anyway, right now I'm sitting next to this machine here, which is the Carvera Air. It's a roughly $2,500 desktop CNC machine that's capable of doing aluminum, wood, plastic, and even fabricating PCBs. And what we're going to do today is actually just use it to build a little macropad project. So we're going to do a wooden case, an aluminum plate. Then we're going to attempt to do a PCB on it because I haven't really tried too much of that yet. I know it's fully capable of the wood and aluminum. But we're going to run it through its paces today and kind of build a project with it and also slightly review it. Now, the reason I say slightly review is that I am going to be talking about this in my niche of mechanical keyboards, but I'm not going to be like doing stuff where I test it in depth on, say, taking a 6mm piece of aluminum and saying, oh, it's capable of 12,000 RPMs at a 0.4 step over. I'm not going to do that. There's better videos out there of people that are more experienced with CNC to kind of do that. I'm going to look at a mechanical keyboard building and kind of do a practical use case of making a full project with it. So with that, what we're going to do, we're going to jump over to my table here. We're going to get some wood fixed to it, and we're going to start milling out some stuff. We're just going to start off with this piece of yellow pine here. I think I'm going to do it on this part, so I'm going to fix this to the bed. And the reason we have to fix this to the bed and don't just use like the clamps that it comes with, if I can grab this here, we have these clamps. We're going to still use these also to kind of hold it even more, but we're going to actually be cutting a piece out of this, and if we didn't fix it to the bed, it basically wobble all around. We're going to be cutting out essentially this. This is kind of a prototype of the case I ran. We're going to cut that out of the wood, and it needs to be glued to the bed. That way it doesn't move all around when we actually do hit the bottom. And we're going to be using masking tape. This is kind of a tried and true CNC method where you use masking tape on the part, then you also put it on the bed, and then you use super glue in between. The kit did actually come with some double-side tape, which works fine too. I just find the masking tape's a little bit easier to deal with, a little bit more precise. But what we're going to do is I'm just going to get that on there, and then we'll hop over to the machine. So now we have our masking tape on both the piece here and then also on the bed of the machine. And all we're going to do is we're just going to take a little bit of super glue. We're going to run a line down the middle of these to get some glue on there. So we put that, and I like to just spread it out a bit. You don't need a lot of this, but just enough to kind of hold it in place, but you also don't want it soaking onto the actual bed. But we'll do that. We'll take our piece and make sure it aligns in this corner here. So put that in. Also pull up these clamps here. So make sure that goes there. Put a weight on top to hold it, and I am using these side clamps here just because it helps with vibration. They're not really that needed on this since I do have it glued down pretty well, but they do help hold it in place quite a bit, so I do like to use them. So we'll just put a little bit of tension on those to hold it in place, and that's basically it for fixing our material to the bed. Now what I want to do is hop over to the computer and kind of show you what we're going to run on this, just so you get an idea of how that part goes or how that process goes with setting this up. So here we are in Fusion 360. We're just in the manufacturer workspace here, and what I wanted to show you just kind of what we're going to do on this piece first. So we have a little setup here called the cutout pass, and I'm just going to actually show you really quick what it looks like. So if I cancel that and I just go right click simulate, this is what's really nice about Fusion. They do have their own CAM software, but I find for like big operations like this, Fusion works really, really well. We can kind of just preview everything. So we're going to start off with a facing path to kind of get our material down to depth. We're going to start doing a roughing pass on the outside to cut out the bulk of the material. I'm going to slow this down a little bit and just skip ahead. And we finish with a finishing pass on the edge to kind of do that. What we do here with CNC is we do a roughing pass first, which will leave a lot of tooling marks, and then we do what's called a finishing path to kind of clean those up. So if I actually exit the simulation here and I go to the cutout roughing pass and go to edit on this, and we go to the passes tab, you can see if I scroll down, we have this 0.2 radial stock to leave, which basically leaves 0.2 millimeters of material on the outer edges of the piece. Now if I just cancel out of this and then go over to the finishing pass, you can see if we open this up, this basically just runs a full depth. So we have on our depth here, stock bottom minus 0.2 on the bottom there. It will basically just go around the edge there to kind of clean it up and make it look a lot prettier, although we can sand this because it is wood. This is a little bit more crucial, these finishing and roughing passes when you're doing like metal. I found on wood, it's not as crucial because it does kind of cut really cleanly, and we're doing pine, so it's not super hard anyway. But what I can do here now is I can actually just go on the cutout, I can go right click, I can go to post process. They have their post processor here. We're going to name this Scotto pad dash cutout. So I'll name that cutout there. We'll save it to my desktop. We'll post that there, and then we will hop over to the Carvera controller program. Now this program is really nice because you can control your device all through here. It is all wirelessly connected. The only weird thing I did find is that if I'm connected to it down here and then I go upstairs to my computer and try to connect there, it doesn't allow simultaneous connections. Maybe that's like a safety thing, I don't know, but a little bit annoying that I have to like run down here, disconnect, and then reconnect upstairs, although it's not that big of a deal because most of the time I'm running it down here anyway. I'm not going to be running it remotely from my room, but besides that, this program is really nice. You can kind of control your machine all in here. You can do like homing operations, changing settings, all that stuff that you'd expect with a controller app. There isn't an iOS version yet. It is on Android because there's like a mount on the device you can kind of mount a device to, which is nice. There is an iOS version eventually coming, but I just use it on the computer for now. But what we're going to do is go down to the bottom left to this file icon. We're going to go into the Scotto pad folder I created. We're going to go upload file, and you see this is the CNC file we just exported from Fusion. We can upload that to the machine. It'll just take a second to do that. And the really nice thing with this machine is that it actually doesn't rely on the controller to operate. So it basically runs the file on the machine. And if you close the controller here, it will keep running, because I've done that a few times. And it's pretty nice that the machine doesn't just cancel out. It just keeps running the job, which is nice. And it will resume once you open the program, so you can kind of pick up where you left off. But what I'm going to do is just close this down. We're going to select the Scotto pad cutout CNC file here. And you'll see this will just load really quick. And here it is in the preview. So you can kind of jog through and get an idea of what it's going to do, all the stuff it's going to run, so you can kind of preview it there. But what we're going to do is go down to this little gear icon, which is the run and setup or config and run menu here, and we basically have our work origin, which I'm going to have to actually set on the machine. We'll kind of do that. I'll show you the scan margin feature here, which is really nice. This is really cool that it does this. It has an auto Z probe, so like on a 3D printer, it can auto level to your material. I'm not going to bother auto leveling to this because it doesn't really matter for a cut on operation like this, but that is useful for when we do a contouring pass later, which we'll talk about. We're just going to set our auto Z probe to kind of be there, and then I'm going to set my origin for this. I'm just going to go like 10 millimeters and 10 millimeters. I think that's probably about fine. What we'll be able to see is that scan margin feature will actually use a laser pointer to kind of show you. So I'm going to jump over to the machine, and I'm going to show you how the scan margin and kind of how this sets up, and we'll go from there. You can't see it, but the machine is flashing blue on the light bar up top to indicate that it wants me to put the probe in. So on the side here, we have this little laser pointer probe, which you can just kind of put into the holder right here. And then I can remove my other tool because I have a tool in there. I'm going to press the top button, and you'll see that will pull up the laser pointer there. That's going to give us a scan margin on here to kind of show where it's going to cut, and then it will also auto level to the material. We'll go back and then get the tool. So I'm going to time lapse through it doing this whole process. Alright, so now that it's scanned the margin, I had to do it a few times to get it right. What it's going to do is now go down, and it's going to actually probe that spot to find out where the top of the material is. So we'll do that. You'll see it will probe. And then what it's going to do is going to go back over here to where it wants me to put the bit in. I have this bit right here, which is a single O-flute, 3.175 by 25 millimeter. Kind of looks like that. So you can see what that looks like. We'll take that. We'll drop out our probe here. Put this into the side. Then we'll take our bit with the quick change here. The quick change is really nice. You just kind of pull it down and it just works really nice. We put that in, put it up, and then we press the top button again. And what this is going to do is use that setter in the back to kind of set the offset. Put that over there. I will close the lid so I don't get dust and stuff everywhere. And it will begin to cut. So it's going to go over here. It's a little bit slow on the setup with the moves. It's always painful watching it do that. But now it's just going to come over here, and it's going to begin with that facing operation. So we'll see it will spin up, and we'll go to the front right, and it will begin facing our material. So, I mean, it's taking off very little at this point. But also another thing you can probably see is it has this dust shoe on it, which is really nice because it's hooked up to my shop vac in the back there. So you can kind of push those chips out as it does that. So now there is the rough block cut out. That took probably like 5 minutes to do for this part. What I have to do now is actually just loosen these clamps on the side here, so I can actually get this piece of wood out. And I should be able to just pull this piece up pretty easily. It will be stuck a little bit, but that'll kind of just come right up. You can see there is our piece that we just cut it out of. And then this part's going to be a little bit trickier to get off, so what I'm going to actually do is take these clamps off. I'm probably going to time-lapse through this because it does stick down really well. You can see that's like really on there, but I'm going to take these off and try to get this off right now. So you can see now that we have this nice little piece of wood that's all nice and rounded off. I think this is going to be the top because it has this blemish in the material here, so that will dig that out. This will be the bottom of the case, which should look pretty nice. So I just have to get this affixed on here now, and we're going to do a ball mill next on the corners here. So I'm going to fix this here, then we're going to hop back over to the computer because I want to kind of explain what the ball mill is because it's actually pretty cool what it does. So here we are back in Fusion, and what I want to just show real quick is how a ball mill works. So we have this contour pass, and what we're going to do is we're going to actually run this twice. We're going to run it once on how it's set up right now. Then we're going to actually flip the material in the machine and then run it on the other half, which should make them align perfectly. It's called a flip operation. So we'll see if this works. I have run into alignment issues before with like the XYZ point, and if I don't get my stock aligned right, so we'll see how it works. But what we have is just a simple 3D parallel pass. It's this parallel pass right here. And we're going to use what's called a ball mill. But basically, if I go to simulate this, so if I right click and go to simulate, you'll see that we have our square. Imagine this was the actual full material, but if we run this, you're going to see it just runs these edges to kind of get that little contour to the case, which is really nice. We'll do that on the edge. It'll just kind of do that all around. If I exit the simulation, you're going to see in the bottom right, this is what's really nice about Fusion. It's going to take about 15 minutes. Accounting for errors, it's more like probably 20 minutes per side. So the machine's prompting me to put the probe in, but I've already done that, so I'm just going to press the top button, and you'll see it will move to start doing that. It will set the height of the probe, and then I'm aiming for a position like right about here on the actual workpiece to align it, and I did set my origin to 0, 0, so it should be right here. So this is going to move over now, and if I got this right, what we're going to see is it's going to actually scan the margin first, which should be right on the edge. So we should see this laser perfect, running right on the edge as we want. So it runs on the edge there. I'll make sure on the back that that is running perfectly there. Yep, everything's looking good so far. Look on the right here to make sure that the laser is running along this edge. Looks about perfect. I mean, maybe a little bit of deviation to be expected, but everything's looking pretty good with that. So I think this operation is going to run correctly, and then it's just going to probe it. So I'm going to go through now. I'm going to actually just stop recording this. I'm just going to get some shots of it running the ball mill. Actually, what I wanted to show is what a ball mill is. This here is a ball mill. You can kind of see how the end makes a ball there, which will just kind of run along that contour. So anyway, CNC is not like 3D printing where you can walk away and eat lunch. You kind of need to watch it to make sure that it doesn't destroy the part randomly because you programmed something wrong or the machine just doesn't explode. Not the machine's fault, just how CNC works. So I get to eat my cup of soup while watching this. In all seriousness though, CNC is not like 3D printing in that you have to manually tell the machine what to do. You don't just drop a file in and it does it for you. So you kind of have to watch it to make sure this stuff doesn't collide. That's one good thing with this machine though, is that it has that laser for kind of outlining where it's going to cut. That saved me a lot of times where I would have like cut into the bed or cut into clamps on the bed. So that's really nice on this machine. But just a note here that CNC is not 3D printing. It is different. It is a lot more manual, a lot more in-depth. I kind of think of it as like a router controlled by a computer that you actually programmed. So anyway, that just finished. I'm going to show you now. So yeah, here's the part taken off the machine. You can see it's kind of perfectly, everything's aligned there. We'll have to do a little sanding because this edge could have probably been pulled in a little bit closer in my programming, but it looks fine. Everything looks good in here. And also, this is a Scotto 34 pine case that I did a while back. Just kind of wanted to show that off. Thought it looked pretty cool. But what I'm going to do now is I'm going to mount this on the thing. I'm going to actually hop into the computer because I want to show the next steps of processes in the inside part. This is going to be the top side. I'm going to use this at the bottom because I think that looks nice. I'm going to mount this down, and then we're going to actually mill out the inside after I show you what I'm doing on Fusion. All right, so here we are in Fusion, and it's time now for the really big operation. The reason I did the contours first, I wanted to make sure that the flip actually aligned, because sometimes when you flip apart, it could end up not aligning. But what we're going to do now is we're going to actually do the inside, so I have it all secured on the machine, and we're going to start with this big roughing pass first to kind of get the bulk of the material out. We're going to do a finishing pass to kind of clean up the edges here, because we're doing the same thing where we leave a little bit of material there to kind of shave off to get a real nice clean look. Then we're going to do the roughing on the bottom here, which I'm just calling it roughing. I'm actually just doing everything. I'm not doing a finishing pass on the bottom because these contour slots don't really matter. Nice nano is going to fit here, and then we're going to put a battery in here. And then finally, we're going to actually have a tool change where we're going to change our tool to a 2mm bit to kind of drill out these holes here for the actual plate mounting with the standoffs. So what I'm going to do is I'm just going to export this, send it over to the machine. I'm going to time lapse this because this is going to take quite a while. This entire thing here says about 38 minutes, probably more like 45, 50 minutes to run this. So pretty big operation. And the vacuum hose is actually going to come in real handy on this because I have ran this a few times in like testing and stuff. It's really nice when you start getting a ton of chips in there. You just kind of suck them all out. It's really good. But with that, I'm going to send it to the machine and I'll be back in like 40 minutes of my time, a few seconds for your time. So here it is off the machine. Everything looks really good. I gave it a quick little sanding really quick. I'm gonna actually finish it with like a tea stain. I'll do that all off camera though. I think it will look nice. The only thing that I messed up though is that these holes are not deep enough. I could have programmed that to be a little deeper. I'm just gonna grab a drill bit and just manually drill them. And then the other thing is that, I don't know if you could see, there's like a crack that kind of showed up inside there. Luckily it's not on the bottom, so that's really good that it didn't show up on there, but I guess it's just one of the joys of working with wood, especially like a soft wood like this. But I think it looks really good. So the only thing left to do now is I have to actually put the USB port up top. We're gonna mount these stock like this in the machine, so this will be the front left here. We're looking at it from the back right now. And then I'll show you what that looks like in Fusion 360. So let's jump into the computer. So here we are in Fusion 360 for the last time. We have our USB set up here where we have the outer and then the inner. Basically we have this recession so that a USB port can actually fit in, and then we have the actual port there. So basically if I just open this up and I simulate it really quick, we're just using a 2mm bit for this. We're gonna come down, so we're gonna drill out this outer part here. Let me slow that down just a little bit. So we're gonna drill out this outer part here, which will just kind of mill that, and then we'll go into the inside and start milling that out. And that will just kind of finally poke through there. And that's really all there is. So I'm gonna go on the machine, I'm gonna set that up now. This will probably take, what will this take? Actually, we can look here. This will take about 1:56. So let's say like 5 minutes to do this. So I'm gonna go ahead, do that on the machine, and then we'll have a fully completed case. So there is the fully completed case with the little crack in there and then the holes that aren't fully drilled through. I could have made my program a little bit longer, but it's fine. I'll just drill with some drill bits. But it looks really nice. We have our port up top there, as you can see. So we have the little recessed section so the port will actually fit in. Everything looks great there. The finish is pretty nice. I am going to sand this a bit more than do like a tea stain. I'll probably just do that off camera because it's easier. But if I actually take this and put it down now and then grab our nice nano, which was kindly sent to me by Typeractive. Whenever I do wireless builds, Typeractive is where I go to. So Nick sent me these for this. Basically, that will just sit in the bottom there, pops perfectly in place, and then you can see we have our port up top just as you expect. And then also, because this is such a small build, we're going to be using a 110 mAh battery this time that will fit in that kind of recessed section down below, so you can see how that works. I don't know how that works with having wood and batteries, technically a fire hazard, but we're living life on the edge here. But other than that, case looks really good. I'm going to finish that up today probably, but this has been a very long day so far, probably about 3 hours of doing this, 4 hours or so, because I do have to record the videos, so there's like more stuff in there. It's kind of also hard to estimate how long the machining was because of that, but it came out great. I mean, it looks really good. And now what we're going to do tomorrow, or well, what we're going to do on this video in a few seconds you're going to see, but tomorrow technically is that I'm going to actually mill the plate out of aluminum. So I'm going to be doing that out of 6061 aluminum, about 1.5mm thick. We'll see how that works with the nice Nano 2 being wireless. That might cause issues, I'm thinking about. So we'll see if that is an issue with the build. I know the machine will handle it. I just don't know if this build will handle it. If it is a problem, what I will end up doing is probably switch to a polycarbonate plate or an acrylic plate because we can mill that too. But with that, I'm going to go do something else now for the rest of the day, and then I'll be back in a few seconds on this video, which is going to be my tomorrow, where I'm going to mill the plate. All right, so it's the next day now, and I just have a piece of aluminum on here. It's basically just a piece of aluminum sheet here. You can see just a thin piece of 6061. This is what test piece here. And what I'm going to do actually is I'm going to pull off this dust chute here. It just kind of comes off like that, and then you can mount the hose up top, because on the side there's basically a little air compressor thing here that will actually blow the chips away and help with cooling. So I have that hooked up to my compressor at like 40 psi, so just gonna kind of blow those out of there. But what I'm gonna do is I'm gonna hop over the computer and show you what we're gonna do on this piece of aluminum. Then I'll just get some nice B-roll of it cutting, and in about probably an hour we'll have an actual plate for this board. So here we are in Fusion 360, and I just wanted to quickly go over a few considerations you have to make when working with aluminum on really any CNC, but specifically this one because the motor isn't the most high power in the world. I believe it's only 200 watts. But what we have here is just our little plate setup inside of Fusion. If I actually go to simulate this, I go right click simulate. What we're going to do first is we're going to start with this normal 3.175 millimeter bit here, and it's just going to kind of gradually step into the material on each hole here. So you see it just kind of gradually works down there. Now the reason for this is you don't want to stall that bit, you don't want to like stall the motor, you want to break the bit, things like that, and it will also give you a much cleaner cut if you kind of gradually work into it. So that's the first thing here. But then also if I actually show you the top of this and I just keep playing this, what you're going to see is that we have this corner radius here. Now this is specific to mechanical keyboards here, where this corner radius is a little bit too not sharp, unsharp, I guess it's a word for it. So what we actually do is if I actually pause this and I skip ahead to this finishing step, what you see is we switch to a different bit. So you can see we have T1 instead of T8 here, and this is a 1.5 millimeter diameter bit. So what this does here is it's going to do the same thing. It's going to do two little finishing passes, so it doesn't do as many steps as the original one, but what it does is it actually cleans up that corner. So if I run this, you're going to see that this corner starts to get cleaned up on each of these and gets a little bit sharper. That way our switches can actually pop in. Now if I just come back in here and I exit the simulation and then show you this, we do of course have our holes that we're doing with that same 1.5 millimeter bit. So we just kind of bore down. You can see it's like a helix to kind of gradually yet again step into the material slowly so it doesn't damage a bit, doesn't stall the motor, things like that. And then we finally switch back to our T8 bit, which is that same one we did for the roughing, where we kind of gradually start to cut out the outside, and then finally we finish the outside. So I'm going to hop over to the machine now and we're going to get this set up to cut out the plate. So I did want to mention too, for this we're going to be using this really cool DLC, so diamond light coating is what that stands for. This like really nice 3-flute bit that I picked up. It cuts aluminum really well. So that's what we're going to be using for the main bulking. And then I have this other little tiny bit is what we're going to use for the actual edges. So we're going to be switching between those. It will kind of prompt us to switch in between. So here's the plate milled out of alumina. As you can see, looks pretty good. The edges are very clean and they're not actually too sharp. That's a problem sometimes with CNCing stuff where your edges can be sharp on metal. Just kind of comes with the territory of that, but it feels pretty good. I might actually polish this up to a mirror finish because it might look really cool. So we'll see if we do that. But if I take this, put it down here, and then grab my case, which I did tea stain yesterday, so you can see it kind of has a darker, like yellowish look to it. And then I also did actually stain the bottom with the weight I put on to hold it, so it dried flat, so it didn't like curve or anything, because wood can warp. So I did stain that, but it doesn't matter. It's on the back, so you're not going to see it. But if we put that down there, we grab our plate, pop it on top. You can see that the holes perfectly align where you'd expect with the standoffs. We have about 1 millimeter of padding on the edges, as you'd expect with my designs. It's kind of what I do, is 1 millimeter padding between the switch plate and the actual case. Just kind of helps with tolerance on the keycaps. But this here looks pretty good. And if I actually grab this, put it down, grab a switch right here, you can see that this will just perfectly pop right into the plate, because the tolerances on this machine are actually incredibly good. So if we actually grab the plate here, I'm going to grab a caliper here, make sure we're zeroed out there. I'm just going to measure this switch hole. You can see they're pretty much dead on at 14 millimeters. I modeled it at 14, so 14 with like plus or minus zero 0.2 or so, 0.1 or 0.01 millimeters. So that's pretty much perfect. Looks really good, really happy with it. I might go buff it and make it like a mirror finish because I will clean up those edges so they're not so sharp too. Not that they're like terribly sharp right now, just kind of something I like to do because it looks cool too. But the next thing I want to talk about in this video, if it's not me buffing this plate, because you might see me buffing this depending on if I do that or not, is we're now going to try to do a PCB. And the way I'm going to start with this is we're going to actually jump into the Makera CAM software and kind of take a look at how it works in there so you can kind of understand what we're doing. And then we're going to actually physically do it. This is the part I'm most iffy on this video because I haven't actually done too much practice with PCBs. So we're going to kind of just figure it out here. So here we are in the Makera CAM software, and I just wanted to briefly go over what we're going to be doing to actually produce the PCB. I'm not going to go super in detail on this because it is kind of really complicated and a lot of steps to this. But if we just look here, what we have is we have a simple setup in our Makera CAM here. We have our front and our back of the PCB. And then we also have, if we look, we have these locating pins on the corners. Basically, they're just little 2mm pegs that are on the actual bed of the machine. So we're able to use those to kind of use this to align it when we flip it over to the backside so that everything aligns on the two layers when we flip the PCB. Now, if we just start by looking at the front here, I'm going to actually hide all my paths here. So what we have here is we just have our Gerber's exported from KiCad, of course, and we have our traces, our pads, and our edges. Now, the edges don't really matter on the front of the board because I'm going to cut those out on the back when we flip it over. But if we actually look here, you can see, I'm going to also hide my pads, we have our traces here. So these are all our traces. You can see just kind of how that is. And basically what we're going to do is isolate that copper from the rest of the copper, and that's really all the traces. It's just copper that's isolated from the rest of the copper on the board. So if I actually look at these and I show our traces here, our little traces path, we're basically doing a contour on the outside of the traces to kind of isolate them from everything. Now what we're going to do is we'll cut those traces out, and then we're going to actually pull the board off of the machine, and then we're going to apply solder mask to it to kind of isolate everything else and make it easier to solder to. Because if you say had this here where there's no solder mask on the rest of it, you'd solder this and it would kind of flow into the parts that you don't want it to, so that's why you solder mask stuff. Now after that, what we'll do is we'll actually pull it on here for another pass. So I'll hide these and I'll just show our pads, and basically we'll kind of come back with this special tool. It's called a scribing tool or an engraving bit. Basically it's like spring loaded. It'll kind of just go through these and scrape off that solder mask so we actually get pads. So that's basically the front of the board. Kind of simple, kind of confusing, but maybe you can kind of get an idea what's going on here. If we actually flip over to the back of the board now, we have the same exact process where we have our traces, we have our pads, but we also have a bunch of other layers here. We have all these little hole layers here where we're basically going to switch to different drill bits to kind of punch those holes through once everything's done. So we do the same process where we do the traces, we pull it off the board, we put the solder mask on, and then we put it back on to kind of scrape that off. And then we switch over to these where we start drilling out the holes. And then finally, we're also going to do the edge cuts here where it will be double stick down so it can actually cut out the edges of the board. Hopefully that's not too confusing. I think you'll get a better idea once we start doing it. So with that, we're going to jump over to the machine and we're going to start milling this PCB, and hopefully it works out good. I want to actually look at the overhead here at this, which is called a copper clad. It's basically a PCB or a blank PCB, copper on this side, and then there's that like fiberglass material in the middle there. So this is what it looks like once the traces are actually engraved into the board. So if I actually put this down and then grab my multimeter here, what you can see is if I connect these 2 points here, we get that beep, obviously. But if I come in here and I click on right here, and then outside, you can see there is nothing because it engraved around it. So that's the same for all of these where they're all now isolated, as you can see. But then if I actually hold on here and then go up to this pad, you can see that pad works. This one works. Next one over, also isolated from the ones next to. I'm just checking that to make sure. So everything seems to be pretty good on this PCB. And now the next step is that we have to actually put solder mask on. Now this part I've been practicing with a lot and it's kind of really hard. This here is solder mask. Basically it's like UV resin. It's pretty much like 3D printer resin, but thicker. So we basically take this, we'll put it on here, and then we use like various rollers to kind of roll it, cure it, roll it, cure it, kind of do that. And then the next step, we'll put it back in the machine and we'll kind of scratch off these pads. So I'm just going to go through, I'm going to put the UV mask on now. Alright, so it's been like a day or two since I worked on this video because you can see here there's a lot of testings. This one is the best one here. These were all roller method and this was like UV resin. Didn't work too great on those. So the solder mask on this though was with a silk screen. So I actually have this thing here, which is just some silk screen mesh. I was able to actually squeegee it on good there. So what I'm going to do is I'm actually running the thing again here. I'm going to use that method with the silk screen thing, which should hopefully work good. And that's kind of doing a good job there. So yeah, now you can see that it's cured on there. Looks really good, very consistent, dry to the touch. Worked on great. So the issue I'm having with these pads right now is, if you can see, they're kind of not fully scraped off, and what I read online is that you might want to run this pass twice. So I have found in testing that does work, so I'm going to run this pass another time to kind of scrape the remainder off, and that should fix that issue. Alright, so now that they completed, you can kind of really see what that looks like with the pads not being fully finished on there, so I'm just going to run the pass a second time. There's the front with all the pads on the solder mask all nice and cut out there. I did run it twice, which worked really well to kind of clean them up perfectly. Now what I have to do next, I actually have to flip this over. So if we flip this over, we're gonna mill the back side with the traces, do the pads, and then also do the drilling step and the edge cuts. And I'm not too sure how I feel about PCBs on this yet. I feel like it's a lot of work for kind of little reward. I mean, I am the hand wiring guy, so that might be part of it there. But what I'm gonna do is just do a big B-roll sequence, because hopefully this goes to plan, and it's just gonna be a lot of stuff. So we'll see how that goes. But I'm gonna jump back over to the machine, and you're gonna see a bunch of B-roll of me doing the back of the PCB now. So there's the back of the PCB, and a note I want to make on this is that it's important to clean it with like isopropyl, because when I was testing this with my multimeter there, it was actually shorting because there was like dust in there. So you want to make sure you clean these traces out, but everything seems fine. I'm going to silk screen it now. Alright, so here we have the PCB. As you can see, it looks pretty good, but I don't know if you can tell on this, but up top, you can see we have this here, but then if we flip it, we have those there. So yes, I did mess up on this, but luckily through the power of YouTube/movie magic, I can actually just grab this PCB here that I made yesterday. It's been about 2 days since I last filmed on this, and you can see that this one looks excellent. Everything is aligned there. So we have our pads aligned perfectly on the top right. We have, well, top right this way, top left this way when we assemble it on the board. We have all our switch holes, our little diode heads. Everything is looking good on there. But now the next thing I have to do with this is only specific to PCBs on this machine, and really PCBs made at home like this. There is no connection between this layer and this layer as it is right now. Although this is a dual-sided PCB, there is no connection there. And what we're gonna do to actually fix this is we're gonna use something called PCB rivets. So if I go over here, these are PCB rivets. Basically, it connects the top and bottom layer. So I'm gonna just put them on the side that I'm putting the switches in. It depends on what you need to connect also, where you kind of put them. But basically, we'll put them in these holes here, and then we'll solder them to the back. And then after that, we'll be able to assemble this as a normal PCB. So I'm just gonna go through and put the PCB rivets in now, and I'll be back after where we can actually talk about assembling the board. So I'm not sure how much of that actually showed on the time lapse of kind of trying to assemble these PCBs, because I pretty much cut it off after I started getting really irritated. Because if we look at these here, I have two PCBs that were kind of functional before this and now aren't really functional because I like ripped off the pads up here. I couldn't get the rivets in there consistently where they'd actually connect, and they're actually breaking the traces when I was riveting them and stuff. Now, I don't think this is entirely a weak point of the machine. I think for what it is in rapid prototyping, it can work. Specifically, have a more simple PCB than this, and this is like for a keyboard where anyone who knows me for any amount of time, I'm the hand wiring guy. In the time it took to make this PCB, I probably could have hand wired this like 3 or 4 times. It takes about 3 hours for these little PCBs here. So it's a very slow process, and then having to connect the two layers with those like pins there, it just kind of defeats it for me, where, you know, I'm basically double soldering this PCB and then waiting all this time to only find out that after I put everything together, it's not connected anymore because I broke traces. So like I said at the beginning of this video, we were going to try to make a PCB. I'm no longer attempting to make a PCB on this as of now. I might revisit in the future, but this video is kind of getting too long at this point, and it's also been going on for about a week of filming that I just kind of want to get it done now, and I'm just going to go through and hand wire the board as per usual. So the next thing you're going to see is a time lapse of me hand wiring this, and then we should have a functioning board. There are the switches in the plate. I'm just using Ochimu browns. I know I've been a hater on browns in the past, but I had some lying around, so I figured, hey, why not? I might as well use them in something. So I'm going to be just using those. I'm going to go through now and just wire up the matrix. So there's the matrix all wired up. That took me maybe like 15 minutes to do. So like I said, very, very quick compared to the PCBs. But what I have to do at this point is just wire the wires to the controller, and that's pretty much it. So I'm going to go through and do that. There's all the wiring for the board. Everything works on. I did test the firmware. That is working successfully also. So all I have to do at this point is take this, pop it into the wooden case here, glue everything down so it holds in. I'll pop the keycaps on, and we have a completed project. So there is the completed macro pad. I think it looks really, really cool with the wood here. The nice yellow pine with a slight tea stain. If I didn't mention how it's done, I basically took a tea bag, some black tea, heated it up, and then kind of ran it along the case and gave it that nice darker look. I did accidentally stain the bottom, not like staining wood, but like an actual stain from the weight I put on it. So we have like these black spots all over, which is fine because it's on the back of the board, but that's there. Looks really nice. I think it works really, really cool. You can see kind of the aluminum plate coming through, and then I did the keycaps. These are my Scotto cap scoop. They're available on the repo for free if you want to download and print them yourself. So they'll be linked down in the description, but I did them in Galaxy PLA, green Galaxy PLA fried bamboo. And I think it looks really nice. It looks really cool. But with that, there's not going to be a typing test on this, obviously, because it is just a little tiny macro pad. But with that, I think this is a pretty good device. So we're going to jump back over there. We'll talk about it a little bit more. And that is the end of this very, very long video. So yeah, that's my very long video on the Carvera Air. I think this is a very cool device, specifically for my niche of mechanical keyboards. I think a lot of my viewers will find this device really cool. You know, having that ability to do aluminum, plastic, wood, and even try to make PCBs on it at home is really cool. I would like to look at the PCBs again in the future. I just kind of ran out of time on this video to do that. So I will look at that in the future, but for now, I'm kind of just putting that on the back burner for right now. I just kind of did what I did of hand wiring because that's what I know. But this device is really cool. They did also send me some other goodies that I didn't show in this video, but I will show quickly right here. The first one being this module here, which is the 4th axis, which is pretty cool. You can do like rotational moves and stuff. I did mess with it a little bit before this video and stuff, but I'm not going to show any footage of that because it's not really... doesn't really pertain to mechanical keyboards too much, but I do want to make like a custom tool specifically for the PCB stuff, like a riveting tool, so I might actually try that in the future with that. And then the other thing they sent me that I'm never going to use on this is the laser module there. And part of the reason why I actually reached out to Makera and asked that they send me this, and why I started looking for a CNC, is that I don't like lasers. I don't like laser cutters because it's just too much risk. In my opinion, it's just too much risk for your eyes to have a laser in there. They're just pretty dangerous. And there's a lot of machines out there that kind of try to do everything. Bamboo H2D is one that comes to mind recently, but that's a whole other topic. But the laser module on this, I also think this is fitting in the trend of machines that are just cramming a laser in it to have a laser, but isn't really a laser machine. This isn't laser glass in here. They just give you goggles in the box here for the laser. So I don't really think it's a machine you should be lasering on. It doesn't seem very safe to me. And then, of course, there's like fumes and stuff that comes with lasers, but that's a whole other topic too. But I'm going to probably just sell this to someone because I'm not going to use the laser ever. But with that, I hope you guys enjoyed this video. I'm going to be using this a lot in the future, specifically for milling metal. I want to do a lot more projects with metal stuff now because I have that ability. But with that, I don't have anything else to say here. Hope you guys enjoyed this, and I'll see you next time.